So Dave gave us a great sort of overview of an application of OAuth 2, this new protocol for enabling applications to send somebody or to get authorization from a central source. And so today I wanted to talk about one use case in particular called trust elevation. And it's sort of a good use case for having something tangible to explain how all this stuff works. And I wanted to start with a definition. Now, the way that I define trust elevation is, I'll give you an example. It's easier for me to give the example. So I go to my bank, I log in with my username and password. It actually looks at my browser and makes sure my browser is trusted. And it lets me do some stuff. But then when I go to add a new wire transfer recipient, it says, okay, we have to send you a SMS message to confirm it's really you. That's trust elevation. The bank was pretty sure it was me, or they let me see my bank account stuff. But then when I went to do something that was a little bit more required, let's say a higher value transaction, they come back and they hit me with some additional step that I need in order to prove that it's really me. So that's my definition of trust elevation. If you actually try and put that in English, you get something like that. So I'm a member of this. There's a standards body called OASIS, and we have a trust elevation technical committee. And we had to put that into English, and we got something like this. And it's sort of accurate because it's like a negative definition, but it says it increases your mitigation of risk, which is sort of a mouthful, but anyway, it is sort of a good definition. Well, I was reading a book the other day, and I came across this quote, and it was sort of interesting to me because I was thinking about authentication, and this quote basically says, technology advancement is basically not having to think about stuff. Like, don't think about it. No, that's not advancement. That's not what we want to do. And so being contrarian and being unconventional, I'm going to tell you, don't use 2FA. Don't use multi-factor authentication unless you have to. That's the idea. The best usability for authentication is never asking you to authenticate, just knowing who you are. That's great. I don't want to do anything. But so what I'm saying is use two-factor authentication more intelligently. Be smarter about it. So when you look at authentication, there's sort of a triangle of security, usability, and cost. Some people would call cost deployability, but to me, like if it's hard to deploy it, it costs a lot. So I think that you can have different sized triangles. You can have a triangle that's great on usability but terrible on security. And I think that whenever you choose a type of authentication, you have to choose a certain triangle, and the triangles have trade-offs. So in this talk, I wanted to give an overview of all the different types of authentication, or authentication is sort of too technical. I like to call it person identification. So I just want to give an overview of what we have. I wanted to talk about OAuth 2 and why that's going to be useful for trust elevation. I wanted to talk about inter-domain trust elevation. When you have an ecosystem of partners, like in healthcare, you need to figure out how to deal with trust elevation when there's multiple organizations that may have done the person identification. And then I wanted to talk about what are the new challenges? What are we able to do today, but what are we not able to do today? So that's sort of an overview. Just to give you a little bit of background on me, so I'm the founder of this company called Glue. We're an open source software vendor. We started about 6 years ago. Prior to that, I started an internet service provider. And so this was in the 90s, 95 to 98. So when people ask me about, how do you learn about security? I always say, well, in 95, everything bad that could possibly happen happened to us, and that's how we learned about it. In the early 90s, it was like really like nobody knew about network security or internet security. It was all being invented, and that's how I got into it. After selling my ISP to Verio, I stayed in the security industry, and I did consulting for a number of years for a lot of big companies, helping them with application security and authentication and directory services. I also, any pigeon enthusiasts out there, in addition to my work, I have pigeons and I have kids, and so come see me if you're a pigeon enthusiast. Okay, so what is Glue? We founded it in 2009. In 2009, I'd been consulting for more than 10 years, working with products like Siteminder and Oracle Access Manager and an IBM security product. And I felt there has to be a way to do this with free open source software, right? And I looked out there and I saw some good tools out there, but I didn't really see anything that a company or an organization could deploy, because what I found is that most of the tools from the large vendors are really a suite of products working together. And while there were individual components out there, there was nothing really that was that you could deploy easily as a organizational security product. So we founded Glue to build that, and everyone's asked, okay, what free open source? How do you make money? Okay, so a lot of the business model is basically this. We serve the free open source constituents, and we think that that's important. We also have a enterprise, a higher cost enterprise service, and we're introducing some new low-priced options for companies that want to have business continuity or disaster recovery. So that's the business model. And we're not Glue, ticker GLUU. I wish we could get that ticker when we go public, but it's taken. This is my version of the on the internet, everyone knows you're a dog. This is so person identification. There's a book called Neuromancer where they talk about the meat space. It's sort of the opposite of cyberspace. And cyberspace is digital. The meat space is analog. We're all walking around. And person identification is all about that problem. We have a digital transaction. I'm going to a web page. How do we know what person's in front of us? And that's analog. And so we have a number of tips and techniques for bridging this analog digital gap. Cognitive, which I have trouble saying, I hope I got it right. So something passwords, much maligned, but it's not the only cognitive method we have. There's patterns, you can pick some pictures, there's a lot of ways to get at something that you know. And then we have biometric. A lot of people are excited about biometric. Basically what I found, or I guess been learning, is that every single thing about a person is unique. Your iris, your palm, the bottom one, it's not fingerprint, it uses sonic technology to take a 3D picture of your whole thumb or your whole finger. I had this great idea for ear authentication. I was thinking, well, my phone's always at my ear. What if I could just do ear authentication? 2 companies have patented that. Your heart rhythm. If you could present your kidney for authentication, I'm sure it's unique. So we're just seeing more and more consumerization of biometric, and also just more and more methods. So we also have tokens. This is something that you have. Biometric is something that you are. So token, like for example, I'm a big fan of YubiKey. You can't see this because you're not Eagles, but on my keychain I carry a little USB. They have a smaller version of that one. So they're great. I like YubiKey because it has no battery. There's a number of battery-operated PIN tokens, RSA tokens, for example. The ones on the bottom, Google's announced that they have a new secure computing environment that they can put on a USB key fob thingy. And it's like a whole computer that they've secured. And so we're going to see more and more of these low-cost, secure devices. And the thing I like about the something you have is that's like a biblical trust model. You know, if you read in the Bible, so-and-so gave so-and-so the key, that's how old that trust model is. So that's something that you have is something that our existing security policies know how to deal with because we're already issuing keys. So it's just some other kind of fancier key. So a lot of people are excited about mobile. This is a picture of Duo Security. You probably know them. They're based here in Michigan. It's a very well-designed mobile authentication app. However, there's I wouldn't say a million, but there's many of these out there, and there's many. The phone is fantastic. It's very powerful. It has a great UI. It has a lot of data. It has a lot of sensors. There's a lot of reasons why we're going to see a plethora of mobile-based authentication technology. And then we have smart cards. So in the old days, we would issue these cards, and they were really easy to forge. And so smart cards put some type of digital chip that made it much more difficult to forge these cards. And smart cards also carry attributes. So for example, they can carry your age. So if you go to, if you have a in Belgium they issue smart cards as a national ID, and you can take that smart card, you can insert it into a beer vending machine. It can say, you're 21 and give you your beer. I mean, so the fact that they carry attributes is handy. There's in new technology, problem is no one has a smart card reader in their PC or phone. So there's new technologies to basically take that idea and put it on an SD card, which you could put into your phone, or perhaps build it onto the phone motherboard, but it's the same basic idea. There's a lot of advances in wearables and NFC. For example, Glue is working with a company that did hospital gowns for people who maybe couldn't talk or couldn't authenticate themselves. This is a picture of a tattoo. They call this a biostamp. There's all sorts of use cases for it, and just one of them is authentication. There's a number of healthcare use cases for this. That thing actually has an antenna on it. I think the use case I got from this article was like instead of dog tags in the military. However, there's a lot of, you could actually use it to make sure the person's taking their meds. You could get sensors. There's all sorts of stuff you can do with it. But we're seeing, the interesting thing to me about NFC is that NFC is writable. It's not just readable. So it's not just like an RFID tag with static information, but you can put a token on it that you can rotate. And we've already seen patented technology around NFC using rotating tokens and using its writable ability. There are some new standards around authentication. If every vendor has their own USB format, that's not going to be great. So what we've seen is that there are standards now for tokens, one called U2F. There's also emerging standards for biometric authentication to standardize the interfaces so that we can see, for example, I believe that with FIDO U2F we'll see a lot more of these tokens. The tokens will come down in price a lot because there's a standard and they can be greatly expanded. So FIDO is super important. It's already, the first FIDO token implementation is supported by Google now and YubiKey, and there's a browser plugin, but there's other ways to do it. So sometimes the way that you act can be used to identify you. So for example, if I wake up in the morning and check Google News and then check the weather, and then basically, actually people are fairly predictable in their usage patterns, and the phone stores a lot of this, and you can actually use big data techniques in order to make a guess as to whether this is the person. I would say in a way it's not authentication, maybe it's more like fraud detection, because maybe you're saying, no, this isn't the person. But it's interesting. We're also seeing that at large institutions with a lot of resources, when you authenticate, they look at a lot of contextual information to figure out if it's you, to do what to reduce the risk of a fraudulent transaction. And for example, just looking at your IP address, if I see that your IP address is in use currently by a known group of hackers, that is a red flag that maybe I need to make extra sure that it's really you. I think that we're seeing that this technology, which was previously just available to large organizations, has been consumerized, and now you can pay per transaction to do fraud detection. There's a number of these services that are popping up. Okay, so when I started in the industry in let's say the late 90s, we used to have this thing called Siteminder level. And if you had password, you had level 1. And if you had password plus certificate, you had level 2. And if you had RSA, you had level 3. And we're like, okay, we'll make policies that say you need a certain level of authentication to get to a certain resource. This has become basically impossible. First of all, with multi-step authentications, what if you combine duo authentication and YubiKey? What number do you get? It's really hard to in a multi-step authentication, to combine these and then weight them relatively. The other thing is that the context matters a lot. So if the person's using their phone to access a website and that phone has been rooted and it has no virus protection, is that password as good as somebody else's password? There's an algorithm that compares password complexity, but unfortunately, one of the challenges is that there's no easy way to boil this down to like a number, as much as we'd like to. So Microsoft did a study, and they compared all the different types of authentication, and I love their conclusion. They said basically, while some authentication mechanisms have better security and some have better usability, none have better deployability. Basically, and this is at the heart of the reason why there's still passwords everywhere, because in my opinion, if every website is a one-off, I saw an article today that said it's going to guide me on how to set up two-factor authentication on 100 different websites, and the prospect of that is this isn't going to happen anytime soon. At least if you have 2 kids and pigeons. It's just like reading privacy policies. If you actually read every privacy policy to every website, I think that would take you several days, and very few citizens have several days to devote to this. So this brings me into the next part of the talk, which is if we want to leverage these new methods of identification, we need consolidation. Consolidation saves money. So in order for us to get consolidation, I will never get to a point where we have one password to get to everything, but we do want to have less places where we manage credentials and be able to use those credentials at more places. So in order to get that, we need standards. Identity is always driven by standards because it's always a multi-vendor problem. You have SaaS providers, you have internally built software, you have off-the-shelf software, you have open source software. There's no way you're going to do a top-down security requirements for that. You need standards and interoperabilities. So the 2 standards that I think are really important for trust elevation are OpenID Connect and UMA, which Dave mentioned both of these in the previous talk. So let's dive into that a little bit, because I didn't want to throw really complicated, sequence diagrams at you. So this diagram, I think, is a sort of a high-level diagram, and it shows some of the characters in OAuth 2. And note the people in there. So we have a person who's using a relying party. So that's the analog digital problem there. Remember that the relying party or the requesting party in this diagram is either a mobile application or a website. So it's not a person. It's some code running that's acting on behalf of a person. So OpenID Connect is all about who are you. It defines APIs that allow the authorization server, which in this case has information about the person. So the OpenID Connect is going to define how does the client register. So you have a website, you need an API key and secret, or something better. Maybe you need a signed JWT. How does the client register? That's the first part of OpenID Connect. And then after the client is registered, how does the client send a person to be authenticated? And once authenticated, how does the authorization server return back information about the person? What kind of authentication happened? And who is this person? What's the person's first name, last name, email address, and stuff like that. So that's OpenID Connect. But if you notice, the action's primarily on the right side here between the person and the authorization provider. So UMA is a little bit different because it assumes you've already been authenticated. So after you're authenticated, we want to know what APIs are you allowed to call. And so UMA defines really three parties. If we look at the bottom one is the requesting party. It's still the application that's acting on your behalf. Let's say a website you visited or a mobile application. On the right side is the authorization server that's making the decision. And on the left side is the resource server. That's the thing that has the APIs that you're calling. So you're using your mobile phone, you're calling some API server. The API server doesn't know if it should give this person using this client access to the API. So it basically is able to delegate that policy evaluation to the authorization server. So instead of storing all the policies on the resource server, let's store the policies in the authorization server, which gives us more leverage. So that's a quick intro of OpenID Connect and UMA. And now, without getting, the point here is not to give you a deep dive on how to implement, but I just wanted to use, to go a little bit into the jargon to give you an idea of how it's used throughout. So I'm going to focus on these two parameters, one called ACR and one called AMR. ACR, I don't know why it only has one C, Authentication Context Class Reference. I guess one of the C's is no one can remember it anyway, so we just abbreviated it. And AMR is, so ACR is a way to say what is the identifier for the authentication type? Are we going to call it duo? Are we going to call it password? Are we going to, whatever we're going to call it, that's the ACR. So it's a pretty simple concept. AMR provides a way to provide additional context about the authentication. If I just tell you we authenticated, X, I might want to tell you like 10 other things, and AMR gives you a way to send back some additional information about what happened. So in OpenID Connect, like the important token is called the ID token. And what it contains is information about the authentication event and the person's user claims. So for example, when does this token expire? When was it issued? At what time did the person authenticate? Perhaps I haven't authenticated the person in 5 days and I've just been issuing refresh tokens. So it contains some information about the event. Here's the ACR and the AMR. What type of authentication was used? And in this case, I'm using AMR. I'm saying, okay, 10. Maybe your organization does have some relative weighting of authentications. Or 2FA is just an example. Perhaps there's a risk score from 0 to 500. I think I put in 324. So basically, US, maybe you want to send the geolocation where this happened. So that's the ID token. So other places were ACR. So starting from the beginning of the transaction, first I had a client, let's say a mobile application or a web browser. Now, my point about authentication is, depending upon what client you're using, you might want to use one type of authentication or another. So Glue has a customer in the TV industry, and if we made you put in your password on your TV remote, you would want to kill us. It would be terrible. So for the TVs, we use PIN number plus device ID plus username. But the idea is that when that TV boots up, we know we don't want password authentication, so we want to request a specific type of authentication. So the client itself can sometimes say, based upon what sensors I have available or what interfaces I have available, I want to request the type of authentication that's best for me. And so in OpenID Connect, a client can say, I'm always going to be a TV, so please give me this type of authentication. So the client can request specific types, default types. Uh-oh, I couldn't read that. What was that? Okay, I did it backwards, sorry. This is the client asking for a certain type of authentication. I guess before that, the OpenID provider can say what types of authentication are available. So if I'm let's say, Google, maybe I offer password and YubiKey. So there's no point in the client asking for types of authentication that the provider doesn't support. So OpenID Connect provides a way to publish what types of authentication are supported. Then again, the client can request a specific type of authentication. Sometimes the client might want to override. So a client can say, even though I normally want TV authentication, in this case I want to do password authentication. So there's a mechanism so the client can override that in the request. And then of course the person gets authenticated and you get the ID token back that says, while you can request multiple types of authentication, you can say, give me Duo or give me YubiKey or give me something, but only one of them can actually happen. So when the ID token comes back, the ACR is single value because only one of them happened at that time. All right, so how can we use this ACR thing? And I'll just give you a simple example in a web application. So let's say we have a folder in our website, https example.com/finance. And we want to make sure that anybody who gets to this finance folder uses a certain type of authentication. So Gloop is working on web plugins, and you could basically, perhaps in the web plugin, say, in order to get to this folder, you need to use this type of authentication. And now I'm going to go back to UMA and say, so that's what UMA allows you to do is something very similar, but there's a very subtle difference. So in the OpenID Connect configuration, I could say I want to require this type of authentication. In the UMA, uses scopes, which is really just a way to send some extra information to the authorization server. So instead of requesting specifically in that folder saying what type of authentication I want, what we can do is say, I want you to evaluate this scope. And then this way, we've not tightly bundled the authentication into the application. So if we decide, let's say, using this approach, let's say we update the policy server to say, okay, we're not using RSA tokens anymore, we're using YubiKey. I don't have to change the app, I don't have to change the ACR. So the other advantage of this type of, this level of abstraction in access management is that I can have one or more policies that determine whether I want to grant access to this folder. There might be one that says, okay, the request has to be from the US. It has to be, this time of day, or using these authentics. So basically, what I'm saying is, by loosely coupling the application with a security infrastructure, we get more flexibility, especially to change. It's very, very hard to change applications, all your applications, when you're under pressure. This sort of brings me to my point about a policy decision point. So in the security industry, we have this jargon, PDP, PEP. PDP stands for Policy Decision Point. PEP is Policy Enforcement Point. The basic trend over the last 15 years has been, whatever policies you can centralize is good. For exactly the reason I just mentioned. To update an application frequently requires you have to go and re-QA the application, retest it. Sometimes you don't know who the software developers are. It can be hard to build. So to the extent that you can centralize policies, it enables you to implement new security more quickly. It improves auditability. There's a number of advantages to centralizing policy management. So, and that's what UMA does. So I'll dive into it a little bit more deeply now. So remember, the requesting party on the bottom is our website or mobile application. It calls the resource server and says, I want an API. And the API, the resource server says, well, before I give you this API, you need to give me an RPT token. And so the requesting party, now at that time, the resource server registers a permission ticket and then sends back this blank RPT to the requesting party. The requesting party then presents that back to the authorization server. The authorization server evaluates all of the policies and either gives or doesn't give the RPT token. Let's say it gives it. And now, armed with an RPT token, the requesting party calls the API and is allowed through. So that's the flow. It enables the resource server to not really know what are the policies. Actually, the requesting party doesn't even see what policies are required. That's only shared between the resource server and the authorization server. So what kind of policies can you make? You can make policies about what type of authentication is required, user claims, the person has to be a manager, client claims, we're only going to let you use the mobile app that we issued, request headers, like sometimes the load balancer will put information in, where's the IP address. Basically, you can make implement any kind of policies you want in order to. Now, what happens if the person isn't authenticated the way you want? Let's say one of your policies is you must use two-factor and the person only use password. So UMA has this capability where, so normally if a policy evaluates false, the policy server is just going to say not allowed, unauthorized. However, that's not very helpful to the person. So I think what we added to UMA was an extra piece of information where you can say, okay, you are 403, you are actually unauthorized. However, you need more authentication, and in fact, there's that ACR again, you need this ACR in order to get through. So it provides a hint to the client so that the client can go and obtain that better type of authentication. How am I doing on time? Okay. So this is part 3. So in certain industries, I think you guys are convinced about this already. You're here collaborating. In certain industries, it's very hard to convince them that they should collaborate with their competitors. But in certain areas like security, it actually pays to collaborate because companies don't generally compete on security. Like you won't hear Google saying Microsoft security is bad. So they can collaborate on this. Okay. So the idea with federations is that by collaborating, we're going to be able to drive down the cost of single sign-on and access management. So this idea started a long time ago. EduRoam was a Wi-Fi federation that came out of the edu industry. Basically, if you needed Wi-Fi access, if you could go to any EduRoam campus and log in with your home credentials. But that was just authentication. It wasn't access to web pages. So also out of higher education came this idea of multi-party federations, where we have a number of identity providers and a number of websites that get together and they form a federation. So the federation is actually an autonomous organization, usually, let's say a nonprofit in the case of InCommon, and there's 500 universities or so, there's about 200 websites. Now the idea here is that a lot of universities use the same websites. So if I'm a university and I'm sharing data with a website, I'm regulated by FERPA, I want to make sure that this website's going to protect the data. So instead of having to read the T's and C's of 200 different websites, InCommon provides one standard participant agreement where all of the parties sign that. So if I'm a university, I know what level of protection the website's agreed to because they signed the standard agreement. So there's legal aspects of the federation. There's also technical aspects of the federation. From the website perspective, they could go do 400 one-off SSO integrations, or they could join InCommon. So it's compelling for them to join. How does this stuff work? So it's simpler than you'd think. Actually, there's one big XML file And each participant that joins gets a little part of that. The in-common metadata is about 10 megs, and it contains the key information and some information about where this entity provides its services and whether it's a website or an identity provider. One great thing about this is that if you need to update your key, you don't have to go to all your website partners. You can just update it at the Federation. So if you have a really bad breach and your keys are compromised, you don't need to tell 50 websites, here's my new key. You just update it at the Federation. The Federation metadata is published every 5 minutes, so all the partners should be set to automatically download the latest data. Federations can also publish schema. So if every website used a different attribute for first name, this would not be good. So In-Common publishes guidelines for schema. Okay, so schema, this is one area where this is a long route, but what I'm getting to is if we're going to collaborate between organizations on authentication, we not only need to define schema for user claims, but we also need to define schemas for authentications, for these ACRs. So when I tell you I did this type of authentication, you know what that means. Okay, so this is text from the OpenID Connect spec. And the OpenID Connect spec itself says how you use these values is up to you. So, and I think that this is exactly where, so this is the working group that I just formed at Kantara. And the basic idea is to take that SAML Federation idea and just update it for OAuth 2. Remember we had that standard for the data. We basically need a JSON equivalent of that. In SAML we had identity providers and websites. They called the websites service providers or SPs, but I call them websites. It was always a website. However, in OAuth 2, we have some new actors. So OpenID Connect, they change all the jargon. So instead of identity providers, we have OpenID providers. And instead of service providers, we have relying parties or clients. But you have your IDP and your SP in there. It's called OpenID provider and OpenID client. But we also have these things called UMA authorization server, UMA clients, UMA resource servers, and perhaps other federations might be part of your network. So I mentioned before that we could define schema, ACR, AMR, user claims, client claims. These are attributes about the client, not about the person. So in education, they classify certain websites as research. Or perhaps you have certain mobile applications that are classified as partner applications. So you can use those claims for policy. OAuth 2 profiles like OpenID Connect and UMA also introduce other scopes is left sort of open for the implementation to use. So they both use scopes differently. These also need to be defined in the federation. So already used extensively, federations use in higher education, there's probably about 30 or 40 national higher education federations. The governments have some of the biggest federations. I think the Department of Homeland Security has the biggest federation currently. I think the schema section alone is like 100 pages. I think health and IoT, two good areas. Okay, part 4, almost at the end, almost ready for lunch.
We're going to have to stop, yeah.
Okay, let me just go to the conclusions then. If you are interested in IoT, then come see me after. So my summary is elevate trust when you have to. Any blanket statement saying you use 2FA you should be very skeptical about. That we will never have centralized identity. Your bank and your telco will never give up identifying you. We'll always have consumer identity. This is the internet domain system is by definition decentralized. Each domain has its own identity. And federation is a must-have. And what can you do about it? I'll put in my pitch for FOSS. So the open source and free open source is not the same. In order for us to get better security, we need more people out there with know-how. And in order for that to happen, we need free open source software. If developers can put your code into production and use it, they can't learn about it, and therefore the price or the supply of developers will be low. The cost for the internet is high. We need FOSS. So I would say use FOSS components, not only because it's a better software methodology, but because there's a side effect of your partner ecosystem that needs it. Don't think about single sign-on. Implement central policy management because single sign-on is just not enough. And if you're interested in helping in auto, then come see me. But you'd have to be, that's going to be for about once a week for the next year. And this is the group at Kantara. So yay, lunch. Thank you.
Thanks, Mike.